So, according to the question, the equation of the function is f of x equal to 2x cubed plus 3x squared minus 12x. Okay, points A and B, they are the turning points, and then there is also a point C which is on the graph. Okay, the x value at C is given, the y value is also given. Now, the first question says determine the coordinates of A, right? The coordinates of A and the coordinates of B. Right, now it's important for you to know that if a question talks about coordinates, it means your final answers must be in coordinate form. There must be an x value and there also must be a y value. Okay, you don't just write the x value only and then you stop there. You have to write the x and the corresponding y value. Now, in terms of a turning point, what do you still remember about the gradient at a turning point? It's equal to z. So the derivative is equal to z. Remember, gradient is also derivative. It's the first derivative actually. So if we want to determine the coordinates of A and B, we need to find the first derivative of the function. Then we equate it to what? To 0. Then we solve the quadratic equation. So we are doing the first one. So I've given our function as f of x equal to 2x cubed plus 3x squared minus 12x. Okay, so f prime of x, remember f prime of x is the derivative. Okay, so this will be equal to 6x squared plus 6x minus 12. Right? Then we equate that derivative to 0. So if we equate it to 0, we end up getting a quadratic equation. Right? Now, I also need you to be aware that this first derivative of the cubic function, it's a function itself. The first derivative is also a what? A function. What type of a function? Quadratic. So you can also sketch a graph of the first derivative. Okay, we'll do that later on. Alright? It will be the extra exercise. So let's find the HCD set. Now here I'm gonna solve by factorization. So I'll take a common factor. Okay, then you divide both sides by the common factor so that the equation becomes x squared plus x minus 2 equal to 0. Then you should be able to solve this. So it will be x plus 2 times x minus 1 equals or x will be equal to positive 1. Okay, so what this means is at A, x is minus 2, at B, x is equal to positive 1 from common sense. Right? Then we need to find the y values. Okay? We need to find the y values, so we have to substitute into the original function. So what will be f of minus 2? That will be 2 times minus 2 cubed plus 3 times minus 2 squared minus 12 times minus 2. Alright, so then that will give us 16, and that will give me positive 12, and then we get positive 24. So I'll get 40, then this will give me 52. So when x is minus 2, y is going to be 52. Are you following that? Huh? No, it's not. Because, no, this is minus 8 times 2, so this is negative 16. Okay, it's not 52. I need to remove that. This will be 36 minus 16, so it will get 20. Okay, so it will be 20. Okay, let me correct that. And let me remove this. So the correct answer is going to be 20. Okay, the correct answer is supposed to be 20. Then, when x is 1, so we'll say f1 is equal to 2 times 1 cubed plus 3 times 1 squared minus 12x minus 12 times 1. right? So this will give you 2, that will be plus 3 minus 12, you get negative 7. Therefore, the coordinates of A are going to be x is minus 2, y is 20. The coordinates of B, x is 1 and y is negative 7. Now, I want you to look at this very carefully. I'm going to go further and talk about the first derivative. Okay? I'm going to go further and let's talk about the first derivative. What? Can you write quickly? That are you following me? We are mainly concerned with the x values at the what? At the turning points. Yes.
So, sir, my question is, when you were doing quadratic coordinates, right? So the first one is x. So like this one is negative 2.
Yeah.
X. So is that so let's say the coordinates we're supposed to get are C and D, right? So would you put the first x that you got as the first one, like C, and the second one will be D?
Okay, Mano, listen. Don't complicate the question. Okay? The question is asking for the coordinate of the turning points. At the turning point, the gradient is 0. Okay? Now we know that the first derivative is also the gradient. So, for this question, let's find the what? First derivative. Now, that first derivative, it must be equal to what? To 0. So you take the trinomial to 0 and you create your quadratic what? Equation. Can you stop talking there? You following that? Don't complicate things. Just find the first derivative. You want to find the coordinates at the turning point. Find the first derivative and then you take it to what? To 0. And then solve the quadratic equation. Okay? Now, when you solve the quadratic equation, you find the x value. You find the x values. Okay? You find the x values. If the question is talking about coordinates, means you also need to find the what? The y values. So you substitute the x values into the original equation. Are you following that? Okay, let's go further and analyze now the first derivative of this function. Okay? Remember, I told you that the first derivative of a cubic function is a quadratic function. You took the new doctor. Okay? The first derivative of a quadratic or of a cubic function is a what? A quadratic function. So instead of me starting from here, I hope you are aware that I can start. Okay, I think I'll just start from there, from where I had. So we need to sketch that first derivative. It's a function. It's a quadratic function, which is a grade 11 function. It's part of further analysis. Okay. It's part of, when you learn about the cubic function, like at this stage now, you need to know the cubic function itself. You also need to know the first derivative and the fact that the first derivative is a quadratic function. You need to know how to analyze that first derivative. You also need to know the second derivative, how to analyze. Are you following me? So you don't know which question is coming tomorrow, remember. Right? It may be on the cubic function itself, it may be on the first derivative, there may be a question on the second what? Derivative. Going forward, you need to know that a question on interpretation will test you on the cubic function, or it may test you on the first derivative. You may also be tested on the what? Second derivative. So you must be ready for all those aspects. Are you following me? Huh? Yeah. So let's sketch. Because I want us to do an analysis of the relationship between the cubic function and its first derivative, so that you can be able to visualize it. Okay, so our first derivative is 6x squared. I think that will be plus 6x minus 12 plus 6x minus 12. Okay, I'm sure you can agree with me that the y-intercept is what? negative 12. Now, if
No, sketching the graph.
I'm actually creating a question which is not there.
Oh, that would come out.
Yes, that you can see tomorrow, or you can see in the trials, you can see in the final exam. I said what? Yes, this is part of interpretation. Okay, how do you listen? Okay, look here. Okay, look here. Look here. When we are talking about graphs, there are two things. There is sketching, which is the foundation of interpretation. You cannot interpret a graph if you can't sketch it. Do you understand what I'm saying?
Yes.
Please, it's important for you to know that. If you cannot interpret a graph if you can't sketch it. The question, okay, I'm saying the first derivative is a quadratic function, which is a grade 11 what? Function. Remember you did the grade 11 quadratic function, isn't it? Yes. Have you been practicing?
Yes.
So, okay, all right. If you were practicing, surely you should have met a question that talks about the first derivative of a cubic function. You should have. If you are really practicing, under calculus, I'm not talking about under grade level functions, under calculus. If you have been practicing, you should have met a question like that. If your answer is a no, it means you are not practicing enough. Yes. Okay. Let's carry on. Can you do me a favor? Just, you are very fortunate that you have a highly experienced teacher. So do me a favor. Just follow what I'm doing. Okay. It will make sense to you maybe after tomorrow, after your trial examination, or after your final examination. Okay. So let's carry on. So here, I've already found, remember, when I solved it, here, when I equated f prime of x to 0, all right, to find the values of x at the turning points, right, I got these two values. For the quadratic function, they are the x what? Intercepts. I want to repeat that. When we start from here, okay, these two x values here, they will be the x-intercepts. But for the cubic function, they are the values of x at the turning points.
Can you please just repeat what I said one more time?
Okay? If you consider the first derivative as a function, the x values that we got, right, they are the x-intercepts of the graph of the first derivative, which is a quadratic what? Function. But for the original cubic function, those x values are the values at the what? Turning point. That's the that's a relationship which you need to know between the original cubic function and its first derivative. So the first derivative is also a what? A function. Point of inflection. I'll come to that. Remember, we have got a question there. I'll come to that. Right? Okay. Are you following what I just said?
Yes.
Huh? So your x-intercepts of the quadratic function, they are actually the x values at the what? Turning points. That's very important for you to know going forward. Alright? So, if I want to sketch it, all I have to do is, I don't have to stretch in terms of sketching this because I know my x-intercept, I know my y what? Intercept. This is my y-intercept. Please be aware that as I talk about this function, I'm also covering the grade 11 quadratic function. I'm also covering that as well. Because both aspects can be tested in the same paper. Right? So we look at this value that is the coefficient of x squared. It's positive. So the graph will have a smiley what? A smiley face. So this is a sketch. Right? So if I'm to draw it, right, we have got our two x-intercept minus 2. Okay, minus 2 and 1. So let me put minus 2 here, I'll put 1 there. then we've got a minimum turning point. Now, to find the minimum turning point, it's not to find the minimum turning point itself. We can use calculus, remember, okay? I can find the second derivative of this. I hope. Okay, I'm not going to find the second. Let me use your knowledge of the 11 functions. Remember, if I want to find the turning point, I will use x equals minus b over what? 2a. Remember that? So here, our b value is 6, so it should be minus 6 over 2 times 6. So you end up getting minus a half. Okay? But what is the value of x what is the value of y when x is minus a half? Now to find that value, find this value here, we may have to substitute x equals minus half into the first what? First derivative. Okay? But I'm not going to worry about that. So let's say minus a half is somewhere here. I'm just going to approximate it. Let's say 1 is here. This is a sketch, by the way. So minus a half could be somewhere there, isn't it? Right? Then we have got our y-intercept, which will be minus 12. Then we put it somewhere there. That's a y-intercept. Okay? If I were to substitute minus a half into this expression, what answer would I get? Can someone do it quickly with the calculator? Substitute x equals to minus a half into this expression. What answer would I get? Okay, it will be 6. 6 times a quarter, it will give me 6 over 4 plus minus 3 minus that. Can you do it quickly with the calculator for me? Substitute x equal to minus a half. You're getting negative what? Which is about minus 13 and a half. So if our y-intercept is that, means when I sketch it, it will look like this. Please, this is a sketch. With the turning point, then it goes in. Okay? The y-intercept is negative 12. The y value at the turning point, I just approximated it. It's a sketch, by the way. Right? But you can visualize what I'm talking about. Now, it's important for you to know that you see that x value which is equal to minus a half. Right? It's also equal to the average of the x value at the turning point. Average value, that is if I add x at a, x at b, and I divide by 2, I'll get that value. Am I right? Okay, I'm going to repeat what I said. Okay, look here. I'm saying we are connecting the first derivative and the original cubic function. Right? We are connecting the what? The two. So, I know that at the turning point here, what is the value of x? It's negative a half. Right? I can get that value from the original cubic function. Okay? By using the two x values at the turning point. So, how do I do that? So, just say it will be the x value at the turning point of the cubic function, right? Sorry, of the quadratic function. It will be equal to minus 2 plus 1 all over 2. Then this will give me minus 1 and half. I hope you remember this, that for the quadratic function, if you add this x-intercept and that x-intercept, if you divide by 2, you will get the value of x at the turning point. Do you remember that? Right? Then, if you want to answer now this question here, I'm going to share with you how it also relates to the quadratic function. Right? So, what does this mean to say that a graph is concave up? It means there's a minimum what? Turning point, isn't it? If the graph is concave up, it means there's a minimum what? Turning point. if it's concave down, means there's a what? Maximum turning point. So if we want to answer this question here, we need to know what is the value of x at the point of inflection, which may be somewhere there. Okay? So we find the what? Second derivative. Right? So let's get that second derivative. Let's get that second derivative. So your second derivative is going to be 12x plus 6. Alright? Now remember, when you're finding the value of x at the point of inflection, you have to equate the second derivative to what? To 0. So say 12x plus 6 is equal to what? To 0. Then we solve this. So you get x equal to minus a what? A half. I'm where again I'm going to answer the question on the previous page. Now, do you see that the x value at the point of inflection is also the x value at the turning point of the first derivative?
Just go to this is always the case.
Yes. You following?
Yes.
Huh?
Yes.
The x value at the point of inflection of a cubic function is also the x value at the turning point of the graph of its first derivative. You see, this half here, we got it there. That half there, we got it. Are you following that? Now, please remember that we can also get this value here from the graph by using this method. You know that. But remember here, I use this method for the quadratic function. But I can also use this method here of adding the x values at the turning point and dividing by 2. Here. So if I add x value here and the x value there, if I divide that sum by 2, I'll get the value at the point of inflection. Does that make sense? Wandile, your face is telling that message. I'm not getting what you are saying. But just tired of what now? Okay, so I'm saying if you don't want to find the second derivative, then what you can do is use the x values at the turning points of the cubic function. Add them and divide by what? By 2, you get the x value at the point of inflection. No, you won't lose. It's another method of getting the x value at the point of inflection. So we now know that x here, x at this point here is what? Minus a what? A half. So what would be the answer? The question says for which values of x would f be concave up? How can you say less than half? It's concave up to the right, so how can you say less than? It's greater. Remember, this is our point of inflection. Can I have your attention, please? Remember, this is our point of inflection. The graph is concave up to the right of this point where there's a minimum turning point to the right. The graph is concave down to the left where there's a maximum what? Turning point to the left. So the answer here to be x is greater than minus what? Are you following that? Now, what happens is, in this case here, I can say I've used x value at A, the value of x value at B to determine the x value at the point of inflection. Okay? Also, if I relate to both, sometimes you may be given the first derivative. You should know that, okay, if I want to find my x value at the point of inflection, I must add the x-intercepts and divide by what? By 2 to get the x value at the point of inflection of the original cubic function. Okay? Furthermore, I'm sure you have seen me using that method there. from grade 11, right? I found x to be minus half of the turning point. So you can also use that method there. It will give you the x value at the turning point of the first derivative, which will also be the same x value at the point of inflection of the cubic function. So, just to summarize this, the x value at the point, at the turning point of the first derivative, and you pay attention, the x value at the turning point of the first derivative is also the x value at the point of inflection. If it's not given, normally you should be given the x-intercept. So use those x-intercepts to determine the x value at this point. That x value at this point is also the x value at the what? Point of inflection. Are you following that? Then lastly, we can sketch the graph of the second derivative. Now, the second derivative, you see this, pay attention. You see that, what type of a function is it? It's a straight line. It's a straight line. So we can draw that straight line as well. So here the y-intercept is what? 6. Let's say I put my 6 somewhere there, which means my x-intercept, I just put 0 here. So if I put 0 here where there is f double prime of x, and then solve this, we'll end up getting 0 or 12x plus 6. If I solve this, I'll get 12x equal to minus 6, then I'll get x equal to minus a what? Minus a half. Now check this. This minus a half is also the x value at the what? At the turning point of the first derivative. It's also the x value at the point of inflection. So if we do the analysis, you find that the x value at the point of inflection is also the x value at the turning point of the first derivative. Furthermore, it's also the x value of the x-intercept of the second what? Derivative. So, the graph will pass through this point. So if I want to sketch the line, please allow me to just draw a sketch of it. Okay? I'm going to pass through this point, so I can just draw a nice line like that. So this will be the graph of the second derivative. Okay? So we have here our first derivative, then here we have got our second derivative. Okay? You following? Right? So I expect you to remember this for tomorrow. Everything I say. Okay? Make sure you remember that. Then 10.3, it's a very easy question. You need to determine the equation of the tangent at C. Now, we have already found the first derivative. So all we have to do is substitute x equal to 2 into the what? First derivative to find the gradient. Okay, remember the gradient of the tangent and the gradient of the graph, they are the same at that point. Right? So, f time of x is equal to 6x squared plus 6x minus what? 12. Are you following that? Then let's substitute 2. X equal to 2. So that will give us 24 plus 12 minus 12. You get what? 24. Now what this means is the gradient of the tangent is also what? 24. Are you following that? Remember, f prime is first derivative, which is the same as what? Gradient. So if I want to find the equation, I'll just use this equation here. Where there is y here, I'm going to put the value of y at point what? C, which is the what? The 4. So I'll put 4. Then where there is m there, I'll put what? 24. Where there is c, I'll put 2. If I simplify this, I'll get 48 there plus c. Take the 48 to the left, I'll get minus 44 is c. So the equation is going to be y equal to 24x minus 44. Are you following that? Hello? Huh? We're finding the equation of the tangent at a given point. Okay. Is anybody else got a question? Hmm? Are you following that? Huh? Right. The other thing which I also wanted to just tell you is, you remember your increasing and decreasing functions? You remember? Right. Now, I'm sure you are aware that to the left of the turning point of the graph is what? Increasing. Between point A and point B is what? Decreasing. Then to the right of B is what? Increasing. Now we can also determine that from this graph too. Okay? From this graph. Right? Remember, we've got an x-intercept here, isn't it? Huh? Above the x-intercept, the graph is what? Positive. The y values for the graph are what? Positive. But we know that the y values of the first derivative, they are also the gradient values of the cubic function. So to the left of this point here, the graph is increasing. Now, if you look at the x-intercept here, to the left of the x-intercept, the function is above the x-axis, which means the gradient is what? Is positive. When I say gradient, I'm referring to the y values. I know that this can be a little bit tricky, but your first derivative, right? The first derivative, if you treat it as a function, that first derivative becomes equal to what? To y. You following that? So what this means is, to the left of this x-intercept here, the graph, this graph here, it has got y values that are what? Positive. That means for the cubic function, the gradient is what? Positive. Then, to the right of this point, y values are now what? Negative, negative, negative. Right? But now, those y values, they are also the gradient of the cubic function. Now check this. You go back to the graph, to the right of x equal to 2, you see that the graph is what? Decreasing. So the gradient is what? Negative. So this interval between A and B is equivalent to the interval between the x-intercepts. Are you getting that? Huh? And then to get to this point where you've got x equal to 1, I'm sure you can see that to the right of x equal to 1, the y values are now what? Positive. That which means the gradient of the cubic function is now positive. So we are now at this point. This point here is synonymous to the x-intercept. This one here. There's a relationship. This point where x is 1 is synonymous to that point. Okay? To the right, the graph is now what? Increasing. So you can also relate your first derivative and your cubic function. But that requires a bit of some thinking as well. If you get a question, because you are now working backwards from the first derivative towards the what? The original cubic function. Okay, so I think I've tried my best here. Let's come to this question now. Let's come to this question. Now, please, I want you to be aware that your optimization has got different types of questions. So you have got questions with 2D shapes or 3D shapes. You have got questions that may bring in other topics like geometry, functions, and so on. If you have been practicing, you have seen that. Was at this stage, remember, you have covered all the topics. Remember, yesterday I told that we are now doing probability, the last topic. So you have covered most of the. I would say so far we have done almost like 98% of your curriculum so far. Right? You can write a metric paper and pass without probability. Yes. Yes. Okay. All right. Okay. Let's talk about this question. Listen, I only have about 14 minutes. So the person says, in the diagram, triangle ABC has a base x meters. The base and the perpendicular height of the triangle add up to 10 meters. So the base of the triangle and its height, they add up to what? 10 meters. So what that means is x plus h will give you what? 10. Alright? Then the triangle is mounted on a rectangle BCDE which has a perimeter of 32 meters. So this triangle here, it is put on top of what? A rectangle which has got a perimeter of 32 meters. Now, you need to know what perimeter is. And you were taught perimeter from primary school. Okay? So the first question says, show that the new area of the triangle of the figure ABCDE is equal to that. So we want the area of the whole shape now. Okay? This is not as difficult as you might think. It's not. It's just that from my experience, you learners, you get scared when you see the diagram. You understand? The diagram shuts you down. But it's always good to know that the questions sometimes are not as difficult as you might think. The question can be so easy. Surely you can use common sense. If you want to find the area of this whole shape here, you need the area of the triangle and area of the what? Of the rectangle. Then you add the what? The 2. Isn't it? Yes. Right. So let's find the total area. But we will do it one by one. Right? But we need this relationship x plus h equal to 10. We are going to also need we are going to need to know, based on the perimeter, I'm sure you are aware that if BE is x, okay, it means that that will also be what? That will also be x. Now, the perimeter is 32. How would you calculate the perimeter? You add all the sides, right? That's the easiest way. So, P of rectangle, it will be equal to x plus. Now, the length DE, do we know it? No. But if you read in the question here, it says the triangle has a base of x meters, right? And the base and the perimeter add up to 10 meters. The triangle is mounted on a what? Rectangle. So what we can do, we can use that equation. We can incorporate it into the perimeter. Okay? We can incorporate it into the what? Perimeter. So x plus x, remember, x and x, they are the what? They are the length. But what will be the length of this side? Now our perimeter here is going to be 32. Right? So this will be equal to 2x. Let me call that length, maybe I can call it 2L. Or maybe let me say 2B. Okay, because I don't know. So let me call it what? 2B. So that will be plus 2B. Right? Now, this question here is not, I would say, based on the information that's given here, it's not very straightforward as to what is the what will be the breadth? Huh? Okay, what I'm going to do is I'm going to calculate the breadth from this formula. Okay, because it's not given. So this means I can say 32 minus 2x is equal to what? To 2b. Am I right? Yes. Then divide both sides by what? By 2. So we get 16 minus x is equal to what? To b. Are you following there? Yes. So this will be 60 minus x. And that's also 60 minus x. Are you following that? Yes. Now, since I have determined the breadth of the rectangle, I can now calculate the what? The area. Right? But I need to eliminate h. I'm sure you can see that there is no h in this expression, is it? So I'm going to use this equation to eliminate what? H. What is H in terms of x? So here we can say therefore H would be equal to 10 minus what? Minus x. So this H is equal to 10 minus x. Are you following that? Now I'm smiling. Okay? I now have all my dimensions in terms of what? In terms of x. Are you following? Huh?
Yes.
Yeah. So the question always requires you to do a bit of some thinking. But don't be scared because you saw a question on application. Don't be scared. Okay? Don't be scared. All right? Okay. Can I carry on?
Yes.
So, the area of that figure ABCDE is going to be, let's start with half base times height, is the area of the triangle. So our base is x, and our height, we got it as 10 minus what? X. Plus the area of the rectangle, it's L times B. So our length is x, and our breadth is 16 minus x. So just to check you back. So this B here, that's the breadth. X here, that's the what? The length. Isn't it?
Yes.
Huh? Okay, so let's simplify this. So you get a half. If I multiply this by that, okay, allow me to just, let me just make things a little bit easier for you. So here we've got half x, that will multiply 10 minus x, plus, here it's straightforward with 16x minus what? X squared. Then let's simplify. So here you end up getting 5x minus a half x squared plus 16x minus x squared. Okay? Now, minus half x plus minus x squared. That will give us what? Minus 3 over 2 x squared. Am I right? Huh? Hello?
Yes. Correct.
Okay. When you're doing the question, always check what you're supposed to show. So that you know that you are on what? On track. So I'm smiling already because I got this minus 3 over 2x squared. I got it. So it's a clue that what I'm doing is what? Is the correct thing. Don't answer the question blindly, please. Don't answer the question blindly. Ask yourself whether it's making sense or not. Okay? Then 5x plus 16x, that will give us 21 what? X. So that's the area. Okay? Right? So I have shown it. It's there.
So why is it next to 2?
It's based on the terms we have, the simplification that we do.
So like,
It's algebra. It's not calculus now. Everything I've done on this page here, it's not grade 12. Please. It's grade 9 and 10. It's grade. Okay? Whenever I get a question like this, let's say you can't do the first one. Right? Let's say you can't do the what? The first one. You can use what you are supposed to show in the first one to do 18 point what? Point 2. If you know how to find the derivative, you just find the derivative of this. Then you equate it to what? To 0. You solve for x. At least you'll be able to get those 3 what? Those 3 marks.
And to give you the money.
Okay.
To
So
come at first break, to finance please. That's up here and the
So I'm doing that one now. So our area A is equal to minus 3 over 2x squared plus 21x. Okay? Now if you want to determine the maximum area, determine the value of x, you need to know that we have to find the first derivative, then we equate it to what? 0. Then we solve for x. So it will be dA over dx. So that will be minus 3x plus 21. You have to know your rules of differentiation. Then we equate this to 0. Get minus 3x equal to minus 21. So x will be what? 7. Are you following? Then the last question says, hence determine the maximum area. So the maximum area is A max. We just substitute x equal to 7 into this expression here. So again, you should be able to do what? 18.3. So that at least among these 10 marks here, if you are scared of doing the first one, you get 5 out of what? 10. But not a 0 for the whole question. Always, all the questions that involve shapes and so on, the structure will be like this. The first question will ask you to show. Whatever expression you are supposed to prove, use that expression to answer the next question, and then it carries on. Okay? So our maximum area, I'll just substitute there, will be minus 3 over 2 times 7 squared, right, plus 21 times 7. So this, okay, I'll get, can someone just simplify for me? 73.5. 73.5 square meters. That will be the maximum area. So the x value you got in the previous question, you use it. Okay?